Yeah, hi. Okay, good afternoon. Good afternoon. Hope you are able to see the screen. Yeah, so I have shared my screen with you all. No, it's recording is happening. Hmm. Screen not visible. Now it is visible. Okay, so we are learning magnetism. Yeah, so did I discuss what is 1 ampere with you yesterday? Did I say that 1 ampere is that current? 1 ampere is that current which, if passing through two infinitely long wires separated by a distance of 1 meter, gives a force of 2 into 10 power minus 7 newtons per meter. I think I gave you this yesterday. Yeah, with the force, right? Yeah, so I think we have done most of it. Now I just have a few small questions to discuss with you. So if there is a wire here, and if there is a wire here, suppose the distance between the two wires is d, the magnetic field B into the plane of paper is mu naught I by 2 pi d. So this is I1, so it is I1. So the magnetic field here out of the plane of paper is mu naught I2 by 2 pi d. The force per unit length is equal to mu naught I1 I2 by 2 pi d. In this direction, the force per unit length on this is this much. So this is the force on 2 because of 1. This is the force on 1 because of 2. So you see that mod F21 is equal to mod F12, 1, meaning that forces always exist in pairs. 2, forces, that is action and reaction, act on different bodies. Yeah, so all these things we did yesterday. So here is a question for you now. There's a wire this way, there's a wire this way, there's a current this way. This is I, this is I, this is I1. Okay. Discuss the equilibrium of the second wire. Discuss the nature of equilibrium of the second wire. This is 1 wire, this is 2 wire, this is 3 wire, third wire. Discuss the nature of the equilibrium of the second wire. Is it option A, stable equilibrium? Is it option B, unstable equilibrium? Yes, Ashwin, how did you say that it is unstable equilibrium? This is slide 1. This is slide 2. This is slide 3. Discuss the equilibrium of the second wire. Is it stable equilibrium, unstable equilibrium? Obviously, you will have to prove it. Yeah, the distance between them is the same. If the currents is in the same direction and have an attractive force, when the directions of the currents are opposite, obviously they will repel. Yes. Yeah. Yeah, because the net force is 0. Okay, good. So I got some answers at least. So I'm sure some of you all are at least paying attention. So for the sake of all those of you, see, there is a repulsive force here, right? So if you move it a little this side, the repulsive force becomes more, and it tends to go this way. If you tend to move it a little towards this side, this repulsive force will push it towards this side. So as a result, this is in stable equilibrium. First, the body is in equilibrium because net force is 0. Okay, now a body on which the net force is 0 is in stable equilibrium if on slight disturbance, the body goes back to equilibrium position. So if I pull it a little this side, repulsive force becomes more, goes. If it goes this side, repulsive force becomes more, goes. Okay, it comes back. So this body is in stable equilibrium. Yeah. Now every body in stable equilibrium, if slightly disturbed, will tend to oscillate. Okay. Now can you find out the time period for oscillations? The question is, what is the time period? So the question that I want to ask you is, what is the time period for oscillations? Yeah, what is the time period for oscillations? So, but when it is disturbed along the perpendicular axis, I will come to that perpendicular axis. This Saturday, I didn't fix up anyone actually, but yeah, one of our past students who just graduated from NIT Trichy, I'll be calling him. Karthikeyan is an engineer who's finished his graduation from NIT Trichy this year. So mostly I'll be calling him this Saturday. Yes, Ashwin, you are right. We will discuss that subsequently. Oh, if you had said stable, I would have said unstable, because you said unstable, I said stable. You were the first one to answer, so I just refuted your statement. Okay, so yeah. So can we find out the time period for simple oscillations? So the way we go ahead is this, that this is one current, this is one current, there is another current here. So let this current be I, let this current be I. This current here is I1. Okay, so this is D and this is also D. Suppose I shift it here, then this will become D minus X, this will become D plus X. So can I say mu naught I1 D minus X, 2 pi D minus X is one current, I mean one force. The other force is mu naught I2 by 2 pi D plus X, right? So this is the net force acting on it. This is the net force acting. So from here I can answer the query. So from here I can answer the query. So it will become mu naught I1 by 2 pi 1 by D minus X minus 1 by D plus X. So I can take LCMs here. So it will become mu naught I1 by 2 pi 2x by D square minus X square. Now if X is very, very small, I can ignore this. So this is what? This is equal to the force per unit length. Yeah. So I'll multiply L here so that we will get the value for force. So this is equal to the force acting. Now force is equal to M into A. M is equal to what? Mass per unit length into L. So now the LL gets cancelled. So A is equal to omega square X. So I can get the value for omega, and T is equal to 2 pi by omega. Yeah, this is a slightly difficult question. This is a standard way of approaching questions where they ask you for what is the time period. So what is the time period for simple oscillations? So this is how you find out the time period for simple oscillations. Find out the net force acting on the body. The net force acting on the body is equal to MA. Mass is mass per unit length into L. So get the value for omega square. Okay, so once you get the value for omega square, T is equal to 2 pi root over, omega, 2 pi by omega. Whose mass do we take? Obviously, the wire is oscillating, so we take the wires. What do we do with the mass? Sorry. Okay, I'll explain again. See, we understood that mu naught I1 by 2 pi 1 by D minus X 1 by D plus X is equal to the net force. I'll put a L here, so that net force, L is the middle wire's length. Yeah, net force. Now when I work with this, I will get L mu naught I1 by 2 pi. I'll take LCM. When I take LCM, it will become D square minus X square, D plus X minus D plus X. So that is equal to L mu naught I1 by 2 pi 2x by D square minus X square. Now this is equal to M into A for the middle wire. That is equal to mass per unit length into L into A. So the L gets cancelled. So that is equal to omega. This is why get the mu here. That is equal to omega squared X. So I'll get omega square equals mu naught I1 by pi D square. This is omega square. Pi D squared into mass per unit length. I'll just put it as small m. Yeah. So now time period is equal to 2 pi by omega. So that is equal to 2 pi into root over of pi D squared mass per unit length divided by mu naught I1 I. by pi d squared m by mu naught I1. You recollect the question that we had done. If there was one charge here, if there was another charge here, and I had kept a negative charge. Okay, now it is an equilibrium. Yeah, sorry, now I keep a positive charge. Now it is an equilibrium. If I push it this side, it comes back. If I push it this side, it comes back. So it's in stable equilibrium. We had found out the time period exactly this way, exactly this way. Find the net force. Net force is equal to ma, and a is equal to omega square x. T is equal to 2 pi by omega. So that is the standard approach for these kinds of questions. Yes, Videsh, we take the mass of the wire. Yeah, you want me to explain or just show you the previous slide? Okay, Levin has an interesting point. He says it is 2 pi root over of d by apparent acceleration. How will you find out the apparent acceleration? Previous slide here. Yeah, okay, same thing, fine. Okay, Levin, I don't think what you are saying will work out here. Okay. You missed my inside the root. Yeah, I'm not able to understand your short forms. Oh, Pradyumna, what I did is I changed, because there was two mu's, no, I changed one mu to m. So that, so Anirudh, I changed that one mu to n, I changed it, okay? Yeah. Okay, so if you guys are clear, I'm done. Otherwise, just work it out once again. We will then discuss. See if there are any other questions you want to ask. Then we will work it out. No hurries. Okay. Yeah. So if you all are able to get it, great. If you all are not able to get it, don't worry. This is just a small question. You don't get these kinds of questions in the board exam, but you can definitely get a question asking you what is the force per unit length, and those kind of questions you will definitely you can get in your board exam. So here we have one wire, here we have one wire, here we have another wire. This wire is going in this way, this way, this way. Now in this plane, we saw that it is in stable equilibrium. Okay, but it can also be moved perpendicular to it. So for perpendicular motion, the moment you move it a little away, because both the forces are repulsive, it will go repulsive and it will go away. So this particular wire, for movement perpendicular to the plane of the board, it is in unstable equilibrium. For movement perpendicular to the plane of the board, it is in unstable equilibrium. For movement in the plane of the board, it is in stable equilibrium. Similarly, if it was carrying a parallel current, now when you move it like this, it moves like this. When you move it this way. But when you move it perpendicular to it, then it will be in stable equilibrium. So these kinds of questions have come quite often in different entrance exams. So we should know how to handle them. Okay. So I hope I've been clear. If there are any questions, I will take them. No questions. But when it is disturbed, yeah, it leaves. So I hope I have explained your point, Ashwin. Yeah. But so for infinitely long wire that has charge flowing through it at all paths, why does the movement cause a change in equilibrium? Why does movement we are qualifying the equilibrium. Equilibrium is of two kinds: stable equilibrium, unstable equilibrium, neutral equilibrium. Stable equilibrium means on slight disturbance the body comes back to its mean position. So we are not saying that there is a change in equilibrium. We are just trying to quantify what kind of an equilibrium is it. Yeah, so if I give you a slight tap, you may go a little away and then come back to your mean position. Yeah, but if I give you a large tap, you may fall down. If you're standing on your toes and I give you a slight push, you won't come back to your mean position. But then if you are, so I'm just trying to qualify what kind of equilibrium it is. Yeah, I'm only trying to qualify. Why does it keep on going in the perpendicular direction? Because there is a repulsive force. Because there is a repulsive force. There is one wire here. There is one wire here. There is another wire here. So this guy is going to push it in this direction. This guy is going to push it in this direction. So the resultant push will be like this. So it will keep moving. Yeah, the resultant push will be in that direction. So it will keep moving. So unstable equilibrium. On the other hand, if it carries a current parallel to it, this will be pulling like this. This will be pulling like this. The resultant will be pulled like this. So it will come back to its mean position. So stable equilibrium. So parallel currents, stable. Anti-parallel, unstable. So I hope I've been clear. Yes, Videsh. Ha. Okay. So if you all understand all this, then let's move on. Yes, the rest of you all, are you guys there? Are you able to follow? Yes, okay. Now there is one more question that I would like to give you on these wires. So let me do that. See, this is the y-axis. This is the x-axis. This is the z-axis. So there is one wire here which goes through the point minus a 0 0. There is another wire here which goes to the point a comma 0 comma 0. Okay. Suppose this carries a current like this, and suppose this carries a current like this. Yeah, this is the z axis, this is the x axis. Yeah, now question, draw a graph showing the variation of B along the x axis. So how does B change along the x axis? Okay, draw a graph. So on the x axis you have x, on the y axis you will have B. I want you to draw the graph and show. Two infinitely long parallel wires carrying a current I pass through the points minus a comma 0 comma 0 and a comma 0 comma 0 parallel to the z axis. Yeah, parallel to the z axis. Okay, now draw a graph showing the variation of B along the x axis. Draw a graph showing the variation of B along the x axis. Yeah, I'll wait for 2 minutes before you try and then I'll do the work. Do yeah. Yeah. Okay, so let me see if there are any queries. There are no queries. So what to do? I will do them for you. More than the answer, it is the approach that we take to these answers which is important. This is X, this is Y, and this is Z. Okay. So I have a wire this way, I have a wire this way. Yeah, suppose you are at this point, this is, suppose this distance from here to here is x. So this distance here is d minus x, and this distance here is d plus x. I can't remember, I took parallel wires, so there is one wire this way and then there is one wire this way. Now because of this wire, the magnetic field is out of the plane of paper. Because of this wire, the magnetic field is into the plane of paper, right? So I can say that B is equal to mu naught I by 2 pi d minus x minus mu naught I by 2 pi d plus x. Yeah, now when I simplify this, this looks like mu naught I by 2x. So x I will put pi d square minus x square. Okay, which means that as I approach this wire here, the magnetic field goes towards infinity. So if I have to draw my diagram here, this is minus a, this is plus a. So here the magnetic field is infinity here, and then it goes this way, then it goes this way, and then it goes this way. Okay, so this is how the diagram looks. This is the origin, this is A as minus A. As you reach minus A, the magnetic field of this wire dominates. So the magnetic field of this wire, oh, I'm sorry, magnetic field of this wire is inside the plane of paper, right? Inside the plane of paper means it will be the reverse. It will look like this. It will look like this. It will look like this. Then it will look like this, and then it will look like this. So it will look like this. It will look, I mean, I can't say inverse, but flip it up. Flip it up. Yes, it looks like a tan curve. First is decreases, increases, then decreases to infinity. See, any wire, grab your right hand. So for this wire, it will be out of the plane of paper. For this wire, it will be into the plane of paper. So this will be dominant on this side. On this side, this will be dominant. On this side, outside will be dominant. So on the after the origin, it will be positive. On this side, it will be negative. These are standard questions. This question appeared 3 years back. It appeared in the NEET, in the JEE mains exam. Yeah, this looks like a tan curve. So there are going to be 4 possibilities depending on how the currents go. So these are the 4 possibilities. You can have currents in parallel direction, you can have currents in this direction, you can have one this way, then you can have one this way, one this way. And how are the graphs going to look? So in one case that we have just now seen, the graph looks like this. Now it is negative here, and then again it goes, and then it comes back. Then this side will be this way, this side will be this way. Then the other way, other graphs will look like this. Suppose both are in the opposite direction, then it will look like this. It will look like this, then it will look like this. So these are the 2 possibilities. Now if you change the directions of current, this will get flipped. If you change the direction of current, this will get flipped. See, if the wire is on this side, if the wire is this way, then when you grab the wire on this side, the magnetic field is into the plane of paper. On this side, the magnetic field is out of the plane of paper. When the wire is this way, on this side, the magnetic field is out. On this side, the magnetic field is in. So it can't be a parabola because it comes this way, it will become 0. And once it becomes 0, it goes to the other side. Or I'm sorry, it goes this way, and then once it becomes 0, it goes to the other side. It can't come back here. It can come back here. It can come back here if both have the same direction currents, but in which case it won't be 0 at the middle. At the middle, it will be minimum, some minimum value. So that is the minimum value here. Yeah, I don't doubt if more than 10% of you all have understood, but I'll be happy if all of you have understood. So I'll wait for you to ask questions. I'll wait for you to work it out and then tell me which part of it you don't understand. First, understand the question, what it is. First, understand it. Yeah, read the question again. Those of you who are not able to get it, don't worry. Please write it again and write the question. First, understand the question. Okay, then come back here and then understand this step. How am I writing this? One magnetic field is into, one magnetic field is out. How am I writing that? That is what is the more important thing. Okay, once you understand this, then I'm explaining to you, look, as you come this side, the magnetic field due to this wire is dominating, and that is into the plane of paper. As you come closer and closer to this wire, it will become infinity. Yeah, so we are at infinity, and that is the negative side, right? Because it is minus inside the plane of paper. So we start from the negative. Then at the middle, both the magnetic fields cancel each other. So we are at 0. Now when you're approaching this side, the magnetic field is positive. So it goes this side. So it goes this side. Now when you cross this wire, it becomes negative. When you cross this wire, it becomes positive. Okay. How is the magnetic field into the plane of paper? Grab the wire with your right hand. Grab the wire with your right hand and the fingers. On one side, the fingers will be going inside, and the other side, the fingers will be coming outside. This is a wire. This wire is carrying a current. Okay. Now, if this wire is carrying a current, 1 minute. Okay. Anyway, so this wire is carrying a current. So if this wire is carrying a current, grab it with your right hand. When you grab it with your right hand, look here, the fingers are going inside. This side, the fingers will be coming outside. So for this wire, on the right hand side, the magnetic field goes inside, and then it will come up like this. So they are circles. Magnetic field lines are circular lines. So they'll go down this way, and then they'll come up like this. Okay, so that's why I'm saying the magnetic field is inside. Grab the wire with your right hand. Yeah, the fingers are in the direction of the magnetic field. Now you see it is going inside. Here you see this side it is coming outside. So here the magnetic field. So on the right side it is inside, on the left side it is outside. Okay, so that is how I am able to say. So for every question that asks us to find the magnetic field due to the wire, should we always start by taking a point at a distance x? Yes, yes, yes. That's the way you start any question. Sir, at the starting, when we started writing the equation, why did we have a negative sign between, one is inside the plane and one is outside the plane. You see, if there is a wire which is going, let's say, northwards for me, on the right hand side, the magnetic field is into, on the left hand side, it is outside. So we are between the two wires. So for one wire, it will be right hand side. For one wire, it will be left hand side. So the magnetic fields will be in the opposite direction. Sir, I can't understand the second case. Could you please explain? I will explain. How is the magnetic field into? I have explained. Okay. So the second case is creating some trouble. So let us look at the second case. Okay, the second case is this, that this is the coordinate axis. Now I have one wire which is going this way, parallel z axis, another wire going this way, parallel z axis. But now they are carrying anti currents. Okay, so for this wire, the magnetic field is into the plane of paper, into the plane of paper. For this wire, also it is into the plane of paper. Do you understand that? So it becomes mu naught I by 2 pi d minus x plus mu naught I by 2 pi d plus x. Both the magnetic fields are into, so they'll inside, so they'll get added on. So at this point it will be infinity. At this point again it will be infinity. Yeah. So how will the graph look? So the graph looks like this. It in infinity it is negative, so it looks like this. Then it'll go, when you add at the midpoint, both of them are equal. So dd, so it will become something. Then it will come like this. Now on this side it is negative, so on this side it will become positive. So it will go from infinity. This side is negative, so again it is positive. So it will go like this. Okay. So this is how the graph will look for this question. If you change this way and change this way, this just get flipped. Now both the magnetic fields between the plane will be outside. See, for me, it is asking, sir, do these kinds of questions appear in board exams? No, no, never. The last thing that we did with definition of current is what will appear. Okay, other than that, it won't appear. Which is the easiest chapter in 12th physics according to you? Is it modern physics or the physics containing electricity and ray optics? And actually, the questions, modern physics is easy, but the questions on modern physics are not easy because modern physics is always mingled with mechanics. So they become quite difficult. Ray optics is again very easy. Simple formulas, 1 by V equal to 1 by F is equal to 1 by V plus 1 by U and all that. Very simple formulas, but there are 101 different cases. So how do you apply them? So the whole of physics is the same. Something can be very easy, but I can ask you a difficult question. Something may be very difficult, but I can ask you an easy question. So your approach should be to understand it and then work. I don't know if I've answered your question. Yeah. So if you guys understand it, then I will move ahead. My dear friends, when you guys go for your entrance exam, there will be 13 lakh students who appear for it. Okay. Now, out of 13 lakh students, if you get 30,000 rank, you will get admission to NIT Trichy. Okay. So, you can cancel these zeros, you can cancel these zeros, you can cancel this and this. So, 3 in 130 only will get admission. So, definitely this is not easy. Okay, so that is the approach. The problem in India is not the subject. The problem in India is competition. So you be very happy that you know how to write A to Z. Then the moment you go to some place and check, there will be somebody who knows how to write essays. So it's all about competition. It's not about the subject per se. But of the subjects physics, chemistry, and maths, definitely working on physics enables you to work with your thought process. Okay, so physics helps you. It helps you understand where you are, nothing else. Okay. So if you guys are able to get it, then can I see you guys summarizing it by writing those 4 questions separately and finding out the answer for it? Question number 1, both currents in this direction. Question number 2, both currents in this direction. Question number 3, one current this way, one current this way. Question number 4, one current this way and one current this way. Can you please work out on these 4 questions separately and draw the graphs? In your exams, you get a lot of questions from modern physics. You get a lot of questions from magnetism. The beauty of magnetism is they are all interrelated. So a same question can be done in multiple ways. While in modern physics, it's not like that. There is a simple straightforward way. You just have to get the straightforward way. Okay, so if you've done it, then we will move ahead. If you've not done it, if you're feeling lazy, don't worry. Sunday test will be there forever till your board exams, till your exams come. Why you don't want to write Sunday test? So what is your problem? Why next week no classes? Always, tests will always be there. Classes also will always be there. You guys will have to show me your notebooks. So don't escape. What is house, sir? Oh, I will call you and on WhatsApp Zoom one by one, you will show me your notes. Then if I have to shout at you, I will shout online. You don't have to see me. You can actually put it on mute. I won't even know. Okay, so let's come back. If the job is done, we will move ahead. Okay, so these 4 cases, please work. If you've done it, we will move ahead. Okay. Yes, 1 more minute I will wait and then we will work. Okay, so if it is done, done. Oh, Abhishek R has already put his note online. Is it? How do I check it? Sorry, I am not able to click on it. Okay, please don't joke around now. Let us quickly finish this. Please finish this, then we will move ahead. So if you are doing this, grab it. It is in the it is above. This one is below. So here it is, and this one looks something like this. This one looks something like this. This one looks something like this. For this one it will just be the opposite of it, so it will look like this. So it will look like this. So it will look like this. For this one, inside, also inside, so it looks like this, then it looks like this, it looks like this. For this one, it will be the opposite of it. So it will look like this, then it will look like this, and then it will look like this. Okay, so this is how it looks. Okay, so you have 1, you have 2, you have 3, and then you have 4. Most important thing is to understand the logic. How are we working on it? How is it that we are able to do this? Okay. Now, Naveen, nobody knows when the school will reopen. So when you were in 12th, how hard was physics to you? Were you a bright student? I was a dumb student, but physics was easy for me. Physics was easy for me because I had a friend who would who would like scare me every day. He would come to the school, and then he would give me one problem. I would not have seen that problem in my life. Then he will say, after 1 day or 2 days, he will come and then he will say, hey Murli, yesterday I got this solution in my dream. So, and the solution would be out of the world. Then I used to think, what is this? I am not getting these kind of dreams, nor am I in the real world getting answers for these questions. Okay, so I used to get very scared. First thing is, I didn't even have those kind of questions with me. So forget about anything. But I used to systematically work out Resnick and Halliday. All the questions I would work out. How is that friend now? He didn't make it. He didn't make it because he was just, I mean, basically, yeah, he was a good guy. He made it in a second attempt. He got civil engineering in his second attempt. That is not important. The important thing is, okay, after that, I tried to look for books, and then I started quite early. I told you, no, I went for one tuition. My tuition master threw me out of the class. Once the tuition master threw me out of the class, I had to read all by myself. I would work for 14 hours a day, 15 hours a day. I never worked on time. I would always work on targets. Today, I will finish. What is this? Magnetism. So every day morning, I would sit down and write this. Now, if this takes 3 hours, I am okay. If this takes 5 hours, I am okay. If this takes 10 hours, I am okay. If this takes 15 hours, I am okay. So this is not very important for me. For me, always work was important. Even today, if I decide that I'm going to do a work, I'll finish it. Now, if I have no work, I won't read. I have watched all the movies released in 1991, 1992, 1993. All movies, 100% attendance I have. Okay. Before this, I have never watched a movie. After this also significantly reduced. So for me, everything is dependent on the work. Whatever work was there, I would finish it off. Okay. You don't have to take silence. Those days were very difficult. My dad used to tell me that if you clear an exam, that is the easiest thing to do in your life. You want to do anything else, you keep struggling, whether you are a player, whether you are a singer, dancer, anything. No, I would prepare on my own. I would prepare. Yeah. So basically, yeah, those days you didn't have these distractions. There was no mobile phone. There was no TV. We had no TV in our house. So no TV, nothing. So there is no distraction. No, I won't recommend Cengage over HC Verma. I don't like Cengage, nor do I like HC Verma for that matter. But yeah, HC Verma is still better than Cengage. I don't like Cengage because Cengage gives everything to you as a theory. Okay, Cengage gives everything to you as a theory. See, the difference is that Cengage gives you a lot of formulas. You can't remember those formulas. What was teacher's role in my preparation? Well, I used to go for some classes to my school. I used to check whether I'm in the right direction or not. I would always talk to them and see if I'm faster than them or not. I have to be faster. You guys have to be faster than your teachers. So you also have to keep checking. If sir is able to do this in 2 minutes, will I be able to do this in 2 minutes? Preparation was on my own, but I was also going to school. No, I also had school like you guys. So I am also going to school, and I have also, my teachers used to work out on the board. So when teachers used to work out on the board, I used to work out on my own. Every day we used to play outside. Every day we have played outside from 5 o'clock to 6:30 is playtime. There is no disturbance. It is possible. Any day it is possible. No, over. Class timing is over. So I am also, your class started at 2:20. Yeah, it's over now. Okay, chalo. Bye bye. See you guys again. So I'll tell you, I'm mostly done. Toughest level of JEE. So those years JEE was very different from what it is this year's. We didn't, first thing is for our batch only they introduced screening test. So ours was the first batch where there were MCQs with screening tests. Otherwise there were never MCQs. It was all subjective questions. Yeah. Okay, we'll talk later. Bye. Thank you.
Thank you, sir, and thank you, students.
Yeah. Bye.
Bye.